Excel tutorial, random number generator. Data Analysis Tools package consists of Microsoft Excel add-in for statistical and engineering analysis. This topic is part of Excel for Data Analysis Basic to Expert Level course. Feel free to take a look at course curriculum by clicking link at description box below. This tutorial has an educational and informational purpose and doesn't constitute any type of forecasting, business, trading, or investment advice. Please read full tutorial disclaimer at the end of this video. Random number generation consists of specified number of random numbers and probability distribution random numbers output from number of random numbers and probability distribution inputs. As a formula, here we have the example of the normal probability density function equals to 1 divided by the square root of 2 times pi multiplied by sigma squared. Sigma corresponds to the continuous random variable standard deviation, therefore sigma squared corresponds to the continuous random variable variance. Which is then multiplied by the exponential of minus, and within the numerator we have x, which is a continuous random variable, minus mu, which is its arithmetic mean, that result to the power of 2, then divided by 2 times sigma squared. Again, sigma squared is a continuous random variable variance. Normal probability distribution has a mean equals to mu, and the standard normal probability distribution has a mean equal to 0. Normal probability distribution has a variance equals to sigma squared, and the standard normal probability distribution has a variance equals to 1. Normal and standard normal probability distribution have skewness equals to 0. Normal and standard normal probability distribution have excess kurtosis equals to 0. For the standard normal probability distribution, we would need to standardize the continuous random variable, which is what we do here, in which set is the standardized continuous random variable, therefore equals to, and within the numerator we have x, which is the continuous random variable, minus mu, which is arithmetic mean, and that result divided by sigma, which is its standard deviation. Therefore, that could be interpreted as the number of standard deviations from the arithmetic mean. Great, so let's go into our Excel file so that we can study random number generation with greater detail. Excellent. So here we are within our Excel file. So notice here that at column B, I already did random number generation before recording this video tutorial. If we select here B4 and press Ctrl-Shift down arrow on the keyboard and select the full column of data, we see that the number of random numbers which were generated as a count here in the status bar was 1000. So what we're going to do next is we are going to replicate this column. So we press up arrow, down arrow, so we go into the beginning of the column. So first of all, we're going to do it at column C. So we're going to input at C3 the name of the column, which is random number generation, and the enter key. We copy the format by selecting B3, going into the Home tab, and then copying the format and pasting it. And then we select column C, and once the mouse cursor changes into that cursor with 2 arrows, we double click on it so that it adapts the width of that column to the corresponding name. And we're going to print those random numbers, and we'll do so at C4. To generate the random numbers, we do so using the Microsoft Excel add-in for that data analysis tools, which is found right here within the Data tab. At the right, we have Analyze Data Analysis, and we click on it. So that opens the data analysis window with the analysis tools. So we scroll down and select the corresponding random number generation and click OK. And the next step here is, first of all, we need to specify the number of random numbers. It is suggested to at least specify 1000 random numbers. So we specify 1000. And then here we select the corresponding probability distribution. In this case, we're selecting as an example the normal probability distribution. And as we can see here, we have the parameters for this normal probability distribution, and by default, we have mean equals to 0 and standard deviation equals to 1. Therefore, it will generate random numbers based on the standard normal probability distribution. Therefore, the results can be interpreted as number of standard deviations from the arithmetic mean. So what we do next is the output options. Instead of a new worksheet, we select the output range and specify cell C4 right here. Go back and click OK. So there we have our 1000 random numbers. So what we're going to do next is select B4, Control Shift arrow. So we're going to copy this format, go into the Home tab, copy the format, and then press the right arrow on the keyboard. There we are. And we have the same format. An important observation here is that, as you might observe, we have different results regarding those random numbers being generated. Also, you might obtain different results when doing your own random number generation depending on the random seed used within this corresponding random number generation. Also, as mentioned previously, it's suggested to do at least 1000 random numbers generation, and in this case, by using the standard normal probability distribution for the random number generation, these numbers can be interpreted as a number of standard deviations from the arithmetic mean. Excellent. So now that we finished studying random number generation, let's go back into the slides. And as mentioned previously, this tutorial has an educational and informational purpose and doesn't constitute any type of forecasting, business, trading, or investment advice. Please pause the video now so you can read the full tutorial disclaimer. Okay, so with this, we finish this tutorial. Thank you for watching.